Today we begin a new unit on what we call polynomial functions. And you've done lots of work with things that are actually polynomials, but we generally didn't call them that. Your book defines a polynomial as a function of this form. P of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus lots of dots because you have lots of terms in the middle plus a sub 1x plus a sub 0. Okay, well, what does that actually mean? Well, let's write this in a form that might be a little more familiar to and put in some numbers, and then we'll talk about why we call this a polynomial. So let's use the polynomial. P of x is equal to 4x cubed plus 3x squared plus 5x minus 2. This is a polynomial, and there are several things that you need to notice about this polynomial. First thing you need to notice is that we are looking at one variable throughout this function. We have an x cubed, we have an x squared, we have an x. This one doesn't have one. It could be written as x to the 0 power, and this x could be written as x to the first power. So one variable throughout my function. I've written them in order from the highest power to the lowest power. That is standard form. You need to do that. And there are a couple of terms you need to know. First of all, this highest power, the highest power that shows up anywhere in the function is called the degree of the polynomial. And we define the degree of a polynomial to be the value of the largest exponent. The value of the largest exponent. So in this particular polynomial, the value of the largest exponent is the exponent we find in this first term, which is 3. So this is a third degree polynomial. We also need to understand that the coefficient of that particular term, this 4, is called the leading coefficient. Now, if your polynomial you're working with is not in order when you find it, put it in order. If it can be simplified, simplify it. If you've got like terms that you can add together, add them together. So, leading coefficient is 4, degree of the polynomial is 3. We talk about the individual terms in our polynomial, and this one is x cubed. So, it seems kind of logical, we call that our cubic term. And then we call each one of them in turn. This one is the quadratic term, since it's x squared. We've been dealing with those for a long time now. So it's the quadratic term. Earlier in the year, did lots of stuff in lines. This is the linear term, the x term. And then this term on the end with no x, which remember we could write as x to the 0, is the constant term. The first thing we want to look at in this video is how do we classify our polynomials. And we classify them two different ways. We classify them by degree, the value of the largest exponent, and we classify them by the number of terms in the polynomial. So today we just want to get a lot of words out of the way, a lot of vocabulary out of the way, and we talk about how do we classify them, because those classifications tell us some interesting things about our polynomial. So let's clear our screen here and talk about how do we classify our polynomial when we are classifying them by the number of terms. So, number of terms in the polynomial. And you're going to be familiar with all of these terms, I think. Number of terms. Well, if I have just one term, what do I call that? Where did my n go? There we go. I call it a monomial. You've heard that term before. Monomial. An example of a monomial would be 3x squared. It doesn't matter what the exponent is. All that matters is there's only one term there. If there's two terms, well, you've done this before. Binomial. Example of that, 2x plus 1. And, okay, so you're getting ahead of me. Number of terms is 3. We call that yes, indeed, a trinomial. Example of a trinomial might be 2x squared plus 3x plus 1. Well, what happens if you've got more than 3 terms? Well, I guess we could call it by weird terms like, I don't know, quadomial or quintomial, but we don't. We just say that if it has n terms, that it is a polynomial of n terms. So let's say I have a polynomial that looks like this. 3x cubed plus 4x squared plus 5x plus 6. So how many terms are there? Well, 3x cubed, there's 1. 4x squared, that's 2. 5x, that's 3. 6, that's 4. So we call this, we classify this as a polynomial of 4 terms. Classified according to the number of terms in the polynomial. Well, is there another way to classify them? Yes, there is. The other way that we classify these is by the highest exponent we find in the problem. And the highest exponent we find in the problem we call the degree of the polynomial. We talked about the degree of our example just a minute ago. If our degree is 0, we call it a constant function or a constant polynomial. So any number would satisfy that. 6. You know, so if we had it written in function notation, we might say f of x is equal to 6. So we're looking at a polynomial with a degree of 0. A polynomial with a degree of 1 is a linear function, or a linear polynomial, x plus 7. Whole first part of the year we talked about linear functions. Degree 2 is a quadratic. So if we have 7x squared plus 3. Now notice, we don't care how many terms it's got. We only care what the highest exponent is. So good idea to always put your polynomial in standard form before you start so that it's pretty obvious what your exponent is. Degree 3 is a cubic. 2x cubed plus 4x plus 5 would be an example there. Degree 4 is quartic. Now, your book doesn't always use degree 4 and degree 5, but I want you to use degree 4 and degree 5 with their special names. Quartic, an example would be 5x to the 4th minus 2x. So we're at highest power is 4. Highest power is 5. We call it a quintic polynomial. Quintic polynomial. An example, negative x to the 5th plus 3x cubed plus 5. And if we get a power that is greater than 5, we generally simply refer to it as an nth degree polynomial. You don't care how many terms, only what the highest possible exponent is in the function. So if I wanted a 7th degree polynomial, then an example of that might be x to the 7th plus 4x squared plus 6. Don't care how many terms, don't care what the rest of the terms are, but the highest power is 7. So, 2 different ways to classify our polynomials, by the number of terms or by the degree of the polynomial.